Do you want to learn how to manage network interfaces with Ansible? Let me show you. The first task that we're going to execute is a test. This test is just validating the operational status of those interfaces. As you can see, they're all administrated down except interface 0 because this is the one that I use for out-of-band connectivity. We're going to run a quick show to display the configuration of these interfaces to show you that there really isn't anything on here. Nothing on the interfaces, they're all set to default. For the next task, we're going to configure those interfaces using Jinja templates. Task is executing. This is going to configure all 4 devices. Device is configured. We're going to run our show to view the configuration. As you can see here, we have configuration all of our network devices now. If you want to learn how to do this, I'm going to show you how to do it right now. Welcome to the DevNet Zone. My name is John, and this is part 2 of the Ansible series, and I will be showing you how to manage network interfaces with Ansible. The blueprint for this video is the Cisco CCNP automation, specifically part 1.1, and we're going to be focusing on interface settings. I am running an Ubuntu VM, and if you run these commands, you'll be running the same software that I'm running. This is the lab that I'll be executing my code against. I'm running the free Cisco Modeling Labs environment where I have 2 routers and 2 switches. If you want to reference the Ansible documentation, go to Ansible community documentation, and the modules that I'm gonna be going over are the iOS config and the iOS interfaces, iOS layer 2 and iOS layer 3 interfaces. At any given time, you guys can click into these and you can reference the parameters for those specific modules. This is the tree structure for all of my Ansible automation. I'll be using the same framework for all of the videos on this Ansible series. This is the playbook that I'm going to be executing all of my automation. I'm going to be targeting both the router and the switch group in my inventory file, which has 2 routers and 2 switches, just like you saw in the topology. And I'm going to be specifically targeting the iOS interface role. Let's go check it out. The iOS interface role has 4 directories, has a files directory, task, templates, and variables. For the task, I always have a main.yaml where I import all of these other files. It's just how I like to organize all of my Ansible tasks. This first task is going to configure all of the network interfaces, but these specific tasks are built with the Ansible iOS modules. This second task, doing this exact same thing, we're configuring the interfaces, but all of the syntax is built into Jinja templates. This task is going to display the configuration for those interfaces. This task is a test I created, so it's essentially just going to test the Ansible operational status. This task is going to erase the configuration from our interfaces. This task is going to render the Jinja template to its actual syntax after it's been rendered with the variables files. And then this one is the task that I use to shut or no shut my interfaces. So going straight into the first one, and let me bring up these at least 1 variables file per device, 1 router and 1 switch. I'll set this to be split screen. Okay, the first task that we're gonna be covering is the configuration one. This first task in this file is going to be setting the layer 2 interface, and I'm going to be using the iOS interfaces module. This task is going to loop through the interfaces, just like you see here in our data model. It's going to be iterating through our interfaces, and it's going to be looking for the interface name, description, whether it's shut or no shut, so looking for the state, like you see here, state true, meaning that it's going to be enabled, the mode type, meaning whether it's a layer 2 or a layer 3 interface, MTU, and duplex. For this specific task, because it's set up to only set a layer 2 interface, we add the when condition. And the way this is read is if layer 2 in item.type. So as you can see here, as it's iterating, it's looking for the type key, and you can see layer 2. If we reference our router data model, you're going to see that it is type layer 3. So when this task is executed, the routers are not going to meet that condition, and it's going to skip them. So this is going to set the interface as a switch port. This second task is setting the switch port command for the layer 2 interface. Initially, this first task was supposed to do it, but for some reason, I was running into some errors. So I went ahead and added this second task to actually set the interface as a switch port. And if we reference this real quick, you said it's looking for the switch port.jinja2 file. So if we go look for that guy real quick, look at switch port, as you can see, it's doing the exact same thing. It's iterating through interfaces. So for interface, in interfaces, interface.type layer 2, it's going to enter the interface, run the switch port command. If the mode for that switch port equals trunk, and then it runs the encapsulation.1q command. For some reason, that first task doesn't do it. And it essentially, you need those commands to be able to move on to apply some kind of like actual interface configuration related to access or a trunk. So this one sets the set of parameters that you're seeing here. This second one runs the switch port command or the encapsulation command for trunk interfaces. This third task is specifically for trunk interfaces. So, and now you're seeing that we're using the iOS layer 2 interfaces module. Same thing, it's going to look through the interfaces key. It's going to look for the name. And then we're using the trunk parameter for this. So it's going to set the interface as a trunk. So mode, item.mode is trunk. So if we look through our switch, item.mode, trunk. And it's going to look for the native VLAN, allowed VLAN, and then it's going to apply this configuration to that interface. As you can see, we have a when condition here, essentially saying if item.mode, so if item.mode is defined, is this key present, and trunk in item.mode trunk. So because these other interfaces you see here are set to access, it's not going to meet this condition, so it's going to skip them. So it's essentially only running this task on the interfaces that meet that condition, like Ethernet 1. The next task is going to apply the access interface configuration. Same module, but now you see here we're calling the access parameter and the VLAN. So same thing, we go to Ethernet 2, mode access, then allowed VLAN, and then same condition, except we're looking for access in item.mode. Then it's going to run this task. These next two tasks are specific to the routed interfaces for our routers. So back again, we're running the iOS interfaces module, and then we're calling these parameters. So essentially saying, hey, this is a interface type layer 3. So when layer 3 in type, we look at our router, type layer 3, and this is going to execute against the routers. The next task is going to use the iOS layer 3 interface module. This is actually going to apply the configuration onto the interface. As you can see here, we're calling the IPv4 parameter, and then we're going to configure an IP address. So you see here, it's looking for item.ip. Here's the IP address, and then this interface also has an IP address. This third interface does not. That's why we have the condition set as item.ip is defined, making it optional. If this condition wasn't here, when we finally iterate to Ethernet 3, if it doesn't see that IP key, it's going to essentially have an error, and the script is going to stop. So this makes it an optional. So if this is defined in layer 3 in item.type, execute this task. So now we're actually going to run it. One thing you're going to notice is that because we have these different conditions, you're going to see that when we execute the task, it's going to skip the routers for the switch specific configuration, and then it's going to skip the switches for the router specific configuration. So we're going to call our tag. You see routers are showing up blue. Blue meaning we're skipping in this task because it's setting a layer 2 interface. So switches are all yellow, meaning there was changes made. Same thing, all the routers are being skipped for the switch port specific configuration. Now you're going to see set L3. So now the switches are being skipped. See, switches are being blue, and actual changes are getting placed on the router. It's very important to add those conditions because whenever you're executing your playbook against like all the devices in your inventory, there's gonna be times you can have different device types, and not every task is gonna be able to execute against all of those devices. So it's good to add those conditions to be able to execute your playbook against all the devices, but only the tasks that are absolutely necessary will execute on those respective devices. So as you can see here, anything that's blue got skipped because we don't want to configure a trunk interface on a router, and vice versa, right? We're not configuring IP addresses on switch port interfaces for our switches. What we're gonna do is we're gonna look at the configuration on some of these devices. So let's look at switch 1. So for switch 1, we see that those configurations get applied. So first interface is a trunk, and the next two interfaces are shut. They're not used, but they're access interfaces. Now, if we view the router interface configuration, you're going to see that this has an IP address. This one has an IP address, 10.1, 0.1, and this one is not used. We'll see that router 2 has its own specific IP addresses that are referenced for its own specific YAML file. So if we look at these guys again, see router 2 has its own unique IP addresses, and this has its own unique IP addresses. So we're able to configure each device with their own specific config using these host specific variables. Okay, now what we're going to do is we're going to remove the configuration from these devices, and we're going to apply the same configuration, but we're going to be using Jinja templates. So this clears these interfaces out, get everything back to a fresh start. It's going to shut the interfaces. So if we run our show command again, we're going to see that there's no configuration on any of these devices. See nothing here. We're running on switch 1. No configuration on any of these guys. Okay, now before I show you the Jinja template, we're going to execute it. Conf_j. It's going to apply the same configuration, but this configuration is strictly coming from a Jinja template. That's finished. If we run our show command again, let's look at our switch. Switch has the same configuration. Look at our router. Same configuration. Now, let's look at the Jinja template. So for the task, for the Jinja task, there's only one task. If you compare it to this one, I have a series of tasks with a series of conditions for the specific switch or router. For Jinja, it's just one task, and I'm referencing interface.j2. I'm using the iOS config module. So when I executed conf_j, it literally just called this template, execute against every single device. Let's go look at the template. Okay. So this template essentially has all of the conditions that you saw in that first configuration task, all the different tasks with different modules, but we're defining this in Jinja. Jinja is almost like it allows you to add conditions, kind of like in a scripting language. You can set different loops, different if conditions to be able to differentiate in those deviations in configuration. So we're going to read this top down. So we have our data model here. it references the same variables from our data model. So from the top, for interface in interfaces, just like you've seen all of these, for interface in interfaces, interface.name. So we're going to enter the interface. We're going to run the description command. One thing you're going to notice from this template is you're seeing the actual configuration syntax here, like for like the actual Cisco iOS syntax. The only thing that's different is that the values that we're configuring are variablized, which are getting pulled from our variables here in our YAML file. So again, description, it's going to set the description. And then we hit our first condition. If interface.type is layer 2, like you see here in the switch, we run the switch port command. Next condition. If interface.mode, just like you see here, mode equals trunk, we run our switchport trunk specific command. And then same thing, switchport native VLAN, we're looking for our native VLAN key, and we're looking for allowed VLAN key. Also, if for some reason you don't have this key defined with a value, or someone just never actually set the value itself, like the key is there but the value isn't present, you can set a default value. If this value is empty for some reason, when you go to run this command, the code is going to return some kind of error and stop the automation completely. So it's good to set a default for a lot of these variables. That way you don't run into any weird errors. So we have our default native VLAN, the allowed VLAN, switchport mode, that mode which is trunk, MTU. And then within the trunk configuration, we have other conditions, right? So if interface.portFast trunk, so if we want to enable portFast on this trunk interface, so here portFast, if it's true, our default is false, but if it's true, we run the spanning tree portFast trunk. Else, meaning if it's false, no spanning tree portFast trunk. And then ends this if condition. And then we actually move back up a condition for this, right? So now else if interface.mode equals access, then we run our access specific switch port commands. Access VLAN, mode access. And then now we have, again, conditions within the access configuration. Interface.portFast. If that is true, we run the spanning tree portFast command. Else, no spanning tree portFast. Again, if interface.bpdu guard, like it is here, bpdu guard false or true, it's going to run if true, spanning tree bpdu guard is going to enable it if it's true. Else, spanning tree bpdu guard disable. Then we end that. Then we apply the MTU. And this is just some error handling, right? So if some of these aren't defined, it is just return an error saying invalid interface mode specified. Now we're going up a condition again, like you saw for the if interface.type is layer 2. Now is else if interface.type equals layer 3. So these are now our layer 3 specific configuration. So we go to our router, type layer 3. If interface.ipv4 is defined, as in if this is present, again, remember this guy doesn't have that key specified. So if this isn't here, it would, once it iterates through to Ethernet 3, it doesn't see it, we're gonna have an error. So we have to make this optional. So if this is defined, run these commands. IP address interface.ipv4. So it's grabbing IPv4 and mask, essentially configuring the IP address on that interface, sets the MTU. Else, meaning if these values were set properly, return this error. And then ends the condition. And then if interface.state, so is false, or so if interface.state is true, no shut, meaning enable the interface, else shut it down. All right. The most important thing about managing Jinja templates is before you execute this against any device, you want to make sure that all of the logic that you built is accurate. You don't want to just blindly execute these against your devices. You want to make sure that the actual raw syntax that you're sending is the intended syntax that you want. And we're going to use the render Jinja task to do this. So for the render, the first task, all it's doing is making sure that the files directory is present. When we render this interfaces.j2 template, we're going to essentially feed in those variables files per device, and it's going to create a file per device with its own specific interface configuration. So let's go ahead and execute this task. We're going to enter render as our tag. You'll see 4 files populate here. Let's go ahead and review this. So for the router 1, and let's also bring up those variables that we had here. Okay, so as you can see here, interface Ethernet 1, description is router 2, IP address is 10.0.0.1 with mask, and state is true. Then for the second interface, you can see here, essentially pull the configuration to this specific device. And as you can see here, it's the exact same format from our template. It's just when it met the specific condition, it fell in those variables. So this is a router, so it fell under the layer 3 interface. Excuse me. And it filled those values in. And it did that for each and every device. So this is now a switch configuration. See, the first interface was a trunk, and the next set of interfaces were access. So yeah, and then if we reference the variables file, you're gonna see that it pulled all the variables from this specifically. For our next task, we're gonna go over the test set of tasks. So we're using the iOS facts module, and then we're targeting the interfaces. So what this is going to do, this is going to return a bunch of metrics specific to our interfaces, and then we can create a test out of that. So if we move over to the test, we're going to be iterating through these facts, which when it pulls those facts, we pass them to this output variable. We're able to take this output variable that you see down here on our second task, and then what we're doing is we're going deeper into the dictionary structure. So we're going into output, then we're going to the Ansible facts key, and then we're going into the Ansible net interfaces key. And we're going to pipe that into dictionaries to items. This is going to allow us to do is going to create some labels like item and key so we can reference these specific dictionary structures that we're pulling and create a test against it. So the first condition is if item.value.oper status, so operational status, equals up, then item.key is up. And then else, if it's not up, it's just going to state the operational status. So we're going to run this test real quick and see what it returns after we apply the configuration. Again, this is testing the operational status. These are all the interfaces for all of our routers. Let's run this against just one device so we can have better reference some of this output. So for the switch, we have 2 interfaces that are up and 2 that are down. And this is specifically saying, hey, these are administratively down. What we're going to do is we're actually going to wipe our configuration, and we're going to rerun our test. So this specific task also shuts all the interfaces down. And then we're going to kick off our test to see how the results change. We're going to kick this test off on all of our devices. You should see everything shows down. So you can see here saying that everything is administratively down. The only ones that are up, these are the interfaces I use specifically for the out-of-band management. So I actually don't want to take these down. Only the ones that I defined in my YAML file. For the show task, this is what it looks like. So whenever I run my show tag, I'm using the iOS command module. It's executing the command show run interface, passing the output of show run interface to the output variable. And then I'm passing it to the second task that's running a debug, referencing our output variable dot results. And then we're essentially, because it's a dictionary structure, we're using the map function to reach out to std out lines and um, display the configuration to the interface. If you didn't use this, it's going to display a bunch of dictionary structures. It's going to have like more than what you really want because you're only really wanting to reference the raw configuration. So you need to do something like this to be able to nail down into what you really want from the output variable. For the removing the configuration from the interfaces, I have a couple of different tasks. The one I've mainly been running is this one, which iterates through each of the interfaces in our data model and executes the default interface command. And then it runs a second task where it essentially just shut the interface. So same thing, it iterates all the interfaces and just executes the shutdown command. If you want to target just a specific interface, there's a task here that you can execute. This one essentially just it's looking for the interface underscore def variable, which you can just specify it in your command, and then it'll just set that specific interface to default. So if we use this one real quick, so we're gonna call the default underscore s. Tag key is what we use to pass a variable to your playbook, so int def, and then equals, and then we're gonna just specify an interface. So let's specify interface eth01, and then let's just execute this against just one switch. So switch one. So if you're not trying to like bulk delete every single interface or interface configuration, you can specify this task. You can pass the interface name and then maybe the switch that you want. Let's say you want to do multiple switches, and let's say it's, interface two. These are two connected. Let's say you're decommissioning this connection. You can just set these to default. Thank you for watching the video. If you enjoyed what you saw, don't forget to like and make sure to stay tuned for part 3 of the Ansible series.